Hi, this is Brian McHenry. This is going to be a quick demonstration of some of the new features of our sequential inputs for ease of implementing EDR data into simulation so then you can test, refine, etc. Generally with the EDR, you have reports from Bosch, etc., different vehicles. In those reports, one of the main things you need to make sure you look at are what are the data element sign conventions, and we'll be discussing that in a moment. We also talk about the coordinate sign conventions of msmac3D. If you go to that section in our help file, you'll see that we talk about the sign convention, which is basically per the SAE convention. We also talk about the sign conventions of some other simulation programs. Another video that we recently added was how to bring in those other simulation programs output into our program to display the results so you can compare direct. But we also talk about the coordinates. So here we have some sample data. Notice we have speed on this one, but no steer. This one has speed and steer, but it's sideways. This one has speed and steer. Generally, when we get a report, you can save it as a text file and bring it in space delimited into Excel, and then you can cut and paste and create the charts. For the one we're going to do, we have a Subaru Forester and a Hyundai Tucson, and the vehicles you notice up here, we have the speed, we have the steering input, and then for this one, we have the speed, and we have the steering input. Now, when we look at the conventions, we see that for the Tucson, which is vehicle 2, it is counterclockwise rotation for the steering input, whereas in SMAC and SAE conventions, clockwise is positive. So this would mean we have to change the sign of vehicle 2. For vehicle 1, you notice the steering input is right turn is positive, therefore we keep the sign the same. Taking that data, which we'll go back here and show you the data on this page, you see that we got 3, 5, 8, 6, 8. I just manually put it in there because it wasn't a lot of data, but you can copy and paste, and I'll show that later. So that data we entered into a spreadsheet. You notice we have the speed, steer, and then we calculated the acceleration based upon the change in the speed. And then we went and calculated the speed based on that acceleration just to make sure we had the numbers right. And you see that these two columns agree. Same for the Tucson, we have the speed, then we have the steer. And as we mentioned, the steer, we have to reverse on the Tucson because of the sign convention. So this positive that was in the record, we make negative. And then we have the acceleration that we calculate based upon that speed. And then we do a check to make sure that the acceleration is proper. We also did some charts down here so we can see what it looks like. Now for the simulation, we have these two vehicles and we're not sure where they start. So one of the things you do is, one of the inputs for our program, which makes it easy, is you turn off the collision. We don't want these cars to hit yet because we know for 5 seconds is before they hit. And we have targets. I'll show those in a bit. Now, after clicking on the vehicle, we go to the menu to the right and we select vehicle 1, steering and braking. So now we're in vehicle 1 and we want to put in the steering. So we go back. So now we go ahead and grab the steer. And again, it's the same. We didn't change the sign of this. We just copy. And we bring it over into the simulation. And here's where we paste it. See, paste all and replace. It verifies what you want to do. And there's the steer. And the program will automatically set these for you. Now let's go to acceleration. We go back to here. We calculate the acceleration that we calculated. And these are inputs. So we go paste, input that. And again, depending on what your all-wheel drive, front-wheel drive, rear-wheel drive, we're going to leave these all-wheel drive for right now, but I believe they're both front-wheel drive. And then we go to velocities to show our target velocities. If we go back, zero, we just say, there we go, we save that, now we save it. Now we go to vehicle 2, and we do the same thing. Steering and braking, here's steering first. Steering first, so we go back to here's vehicle 2, steer. And notice we've changed the sign of the steer to what was input. We go to acceleration, which is what we calculated. Now in this, notice I have a half G acceleration. The vehicle was stationary for a few seconds, and because it's a slope terrain, it would roll, so you just put in some form of deceleration. Since it's not moving, it won't make any difference. And then last, we want to put in our velocity. Say OK, and we go ahead, and now we want to make sure we'd already brought these vehicles in for the specs, for the weights. We just, or if you want, you could change it. You can just go here and, well, it's running right now because I clicked that, said OK. But you can turn that. If you notice, when you go in and look at the inputs, you can turn off the auto run. But what I was going to show is that click here, and we can go to specs, and then we could go and grab a different model, make, or whatever. But let's just assume we've already done that. If you look at our other help files, and now we're going to run the simulation. So we'll just, I have this on. One other thing is we have in here, show multiple exposure. Let's turn those both off, and let's just go ahead and use the slider bar. You see they run, and it could be pretty good, but let's now, before we do that, we want to see, well, how do the speeds compare? And here's the speed of 1 and 2. It's pretty close. So what we want to do is, it looks like we take that to the side. Let's make it a little smaller. Let's bring up our acceleration. Now you notice we're pretty well matched for vehicle 1, which is blue, up until about 2.5 seconds. We need just a little bit more acceleration. So if we go to vehicle 1 at 2.5 seconds acceleration, we have 0.12. Let's make it 0.14. And then at 3 seconds, we probably need more than that, so let's make that 0.1, make that 0.1, make that 0.1. So we've just changed it up to about 4.5 seconds, and then we'll see how that does. For vehicle 2, looks like we have, let's go ahead and slide this over a little. Vehicle 2, we have acceleration 0, but then at 2 seconds, 1.5 to 2, you see that we might even try putting this at a little less. Let's make that minus 0.2 so it doesn't have to come off as much. And then we have at 0.1, it looks like the slope looks pretty good until near the end. So it looks like, well, let's just see what it does. Now how we do that, now by changing that, let's go, that's vehicle 2 acceleration, copy. We go ahead and edit out of here. This is vehicle 2 here. We go and change steer braking, go to acceleration, paste, yes, and OK. Then we're going to go to vehicle 1, which we've made some more changes to vehicle 1. Is here. Copy. I'll go to vehicle 1. Paste. Yes. Okay. Now we go ahead and run. Now we look at the acceleration and the speed. We're matching it pretty good. Right around 5 seconds. We seem to need to have this a little higher. And that's for vehicle 2. Otherwise, we're looking good. So if vehicle 2 is here, and we can manually go do it, or I'd like using the chart here. So if we go to vehicle 2, the acceleration, see we dropped to 0.17. Let's make that 0.4. So it's similar to the other one. So we go ahead and now we grab this. Go in here, paste that, and we say OK. Now we go ahead and run again, and we look at the comparison, And we're matching it pretty well. Now let's see what their trajectories look like. That's not a bad match. Now we'll go show you the evidence we had in this case. First, we have a picture of the vehicles at rest. We see where they met. And another interesting with the video cameras that we have nowadays, we have a video pre-impact of the Tucson. You see where it stops and you can see where it hits and rotates. We'll play that again. Hits and rotates. So now we've iterated on that based on those rest positions and come up with an approximate match here. We're not really doing the final run here. It's just a question of who came out first, etc. But you see we now kind of somewhat match that rear view and then their rest positions, etc. And then when you look at the damage. One other thing that you want to match in this, as we watch this run through one more time, is what is the delta V? Now we have a shortcut here for collision information, which tells you here that we hit it about 5 seconds. That's where we wanted to hit. And then our delta V is about 15 and 19. Let's go ahead and look at what the delta V in the actual reports were. Now when we bring up those reports, I grabbed the charts out of there, and up here you notice it says that for vehicle 1 about 14.9 longitudinal and 4.3 lateral, and here's the charts of that. And then for vehicle 2, we have the longitudinal about 18 and the lateral about 5, and then it actually also includes in addition to the delta V, it includes the acceleration. So one of the things we can do is plot the acceleration from our SMAC simulation versus this, and while also comparing the delta V's. Looking back at that collision summary, we see that we had 15 and 19.9, and that's getting close. They're also on the output files. For those of you familiar, you click here and you go run summary. That also tells you the delta V's and the impact speed, etc. It has a summary of it. From the EDR report for vehicle number 2, we had these tables for milliseconds and the lateral acceleration, which we then put into Excel, plotted, and then we brought in the acceleration from our SMAC run, which is the dashed and dotted lines are the actual EDR data, and then the solid line is the simulation data. Here's a close-up of that again. You see a pretty good match. Obviously we could change the stiffness somewhat, but if we had the acceleration for the other vehicle too, then we could get a good match on both of them. So then taking that information from the EDR and inputting it into the simulation and running the simulation on the actual terrain or a good representation of the terrain, and we can compare both the pre-impact and the impact data and get a better picture of exactly what happened in a collision. There's more information in the help file, and here let me just show you. Easy way is click on the help here and go to help documents. Either getting started or SMAC, they're both the same. They've been combined. You see we have sequential inputs for steer and braking, and then there's a couple of notes on it, etc. And there's more information in the help file. Please let us know if you have any questions, and thank you for watching.